Okie dokie. Oh, what do we have? Some curtain action? Oh, hell no. All right, we're better. Okay, I need to do a quiz. I had an alarm at 12. I haven't been studying C++ like crazy. I do it for 15 to 20 minutes every day, or well, every weekday, which is not much. Every weekday, 15, 20 minutes ish. And I upload those videos every weekday because I get to work like 25 minutes early. So it takes me 5 minutes to set up, and then I get like 15, 20 minutes in ish, and then I got to do work because it starts at 8. So that means that I've been focusing only on new shit, and I've been neglecting the old shit. I'm no longer doing my detailed, in-depth study because right now I'm focusing on the game dev. I have the programming foundation, not a strong one, but I have one. And I needed that way I could actually make progress in the game development, and it's working very, very well. It's awesome. And I don't want to change anything about my study. However, like at least, I don't know, once a month or once every few weeks or something, at least once a month for now, I need to do like a 3-hour review everything and lock it in the brain, because I still remember the quiz that I took where I was like, bro, what the fuck are unnamed namespaces and what are inline namespaces? But now they're locked in the brain. We use unnamed namespaces to give internal linkage to... I guess I'll just say to give internal linkage to things that are in other namespaces, or to just, would I want something inside the unnamed namespace there? Basically, we use it to... Encapsulate isn't the word, because encapsulate, I guess it is. It's to hide and encapsulate certain things from other files. For example, I could define functions. For example, like we'll do... Yeah, I'll do an example really quick. Let's get the JoJo music going real quick. I'm feeling JoJo. I'm going to do another file, and we're going to call it unnamed. And we'll just do... Oh, actually, sorry. We're going to do... This needs to be a C++ file. Get this hair out of the way. All right, got to delete this. Don't need it. Cool. I didn't actually delete it. I pressed enter. I don't think it deleted it, just like removed it. So if I have a namespace and it's unnamed, this exists just like this, okay? There's nothing in main right now, so we'll do name. Oops. Okay, so now we're cool. But here, let's say that I have a function. Let's say that I have a function in main. Void do thing. It doesn't do anything. We'll just say that. And then here, I have void do thing. Oops. Boom. We get an error before I even read what it is down there. We get an error because we're going to see do thing is defined multiply. It's defined in multiple translation units. This guy is compiled. This guy is compiled. Do we see any output? Here we go. We compiled this guy. We compiled this guy. And then we generated the code. So we converted those into binary. And then we link all the shit between those and deduplicate anything that's defined inline. So for example, if I make this inline, now we're cool. But because it's not inline, we can't define it multiple times. We're going to get a multiple definition error. It's the or redefinition error. What do we call it? The ODR, the one definition rule. So this guy is defined 2 times inside our program. Can't have that because these are global functions. So what do? What if I have some shit that I want to do in this file and I want it to use do thing? I could do this. We could say namespace stuff. I'm just going to call it stuff. And I'm going to move do thing to be inside stuff. And let's say in here, let's say do thing. Let's say this do thing actually has a body. Well, trying to think of what I actually wanted to do. Fuck it, I have another function. and it's called void test. All right, hold. Void named wrong. Test. What does test do? Excuse me. I don't want to include it twice. Oh, it doesn't matter, I guess. We'll just say that test prints a thing. So one, it calls do thing, and it says test, okay? Well, I don't want this do thing. Well, actually, it doesn't matter in this case because now it's already within another namespace. Now we're already fine because these are in separate scope. But if I wanted to somehow hide this from other files because, fuck, I'm trying to think. How do I want to do this actually? This isn't a great example. How would I want this? I don't know, I never fuck with unnamed namespaces. And we use it instead. I mean, I guess you could say this too. So you could say, if there are some functions here, like what if we did void do thing? Okay, we get multiple definition error. But if I make this guy static, now this guy is not, well, hold. Oh, well, it doesn't matter. It's not being used, but this, if I had this specific warning turned off, we'd be fine now because this function is not visible to the linker. So when the linker checks this guy, or when the compiler checks this guy, he says cool. When the compiler checks this guy, he says cool. And the linker sees this guy. The linker separately sees this guy. But actually, sorry, the linker doesn't even see this guy. So he doesn't see that there are two functions, both declared in global namespace, both called do thing, both taking no arguments, both returning void, nothing. And we won't get an error that way. But if I had a bunch of these, so if I had a bunch of other functions in here that are like do thing, like we'll just say would do thing 1, would do thing 2, okay? And then here I have would do thing 1, oops. Would do thing. Okay. We get 3 ODR issues because they exist in both of these guys in global namespace, 2 separate CPP files. They both exist in the same bucket of the global namespace. There are 2 copies of each, so we get an error for each one of them. And then we get a general one about just the ODR in general, the one definition rule being violated. But then we get a separate one for each violation. Well, how do I fix this? I could, but hello? What is happening here? I can't just put them all in one? Really? That's fucking annoying. Okay, well, I was hoping... Oh, I guess... Okay, that works. I could just put them in an unnamed namespace, and now we're cool. Why? Because this is a namespace. This is a separate scope. This is not global scope, so they're no longer in the same bucket. We have split them off. And if I called this namespace test, it's fine. And then I can access those. Actually, they're not forward declared here. We could just say... in the global namespace, using namespace test. Oops, it's capital. Wait, hold. Oh, it actually needs to be, wait. Right. Wait, hello? Oh, it's not even, well, hold. I guess it hasn't even seen that namespace, so it would need to be, would it need to be included here? Hold. I guess we would need to include it because it doesn't even see that namespace. Doesn't even see that it exists. Oh. So could I don't remember. Do we just forward declare namespaces? What if we just said namespace test? I don't know why I put an S there. Okay. Using namespace test. No, because we still need to forward declare all the shit that's in it as well. So we could have void do thing void do thing 1, void do thing 2. Hold. Cool. And now we're cool. The definitions exist here. The namespace is here. But we also include that namespace here so that the compiler lets us use it here. And we also need for declarations so that the compiler knows what is actually inside test, what actually we're using. If we were including IOStream, then it would already have this. We don't need to do a using namespace. We already see all that because there's all this code above here precompiled. So I could do this if I wanted to access it, but if I don't want to access these and I just want to prevent the violation of the one definition rule by having multiple definitions of the same function in the same scope, then, or in global scope, or yeah, the same scope, well, I could just remove that, leave it an unnamed namespace, and then if I had another namespace, we could have namespace test. And this whole thing, okay, really? Okay, now we could do unnamed namespaces, put the things inside of it, the variables and functions, in the scope of the scope the namespace is in. So in tests scope. So we can use it here. So I could have another function. Excuse me. Fuck, what is it? Okay. And it calls do thing. And it calls do thing 1. And it calls do thing 2. And then I include it up here, namespace test, and we have a function called void. Hold. What's happening here? That's it. Void test. Okay. And I could go in and now use test. Boom. And use it. That way, from here, I can't do test any of these guys. Why? They're in this guy's scope. They can be used here. Only in this file because unnamed namespace puts objects functions inside it, or rather makes them have internal linkage, which hides them from the linker. Boom. Okay. Oh, and then inline namespaces are helpful for if I have some stuff. So let's say I have, let's say that we have, sure, a namespace. It has a name, just called test. And it has a function that's void test, and it does some stuff. Okay, I need to define it somewhere, so we'll say namespace test, and it does some stuff. So we'll have void test, and it does some things. This compiles because it's defined elsewhere. What is this error? It says function definition for test not found. Oh, because it's not being used, so it's fine. Now it's good because there's a definition. We weren't using the for declaration, so like just like if we said void thing, it still compiles because we're not using it. If we were actually using it, then we have an issue because there's no definition found. The linker's going to say, hey buddy, sure, the compiler found him, good, but I'm the linker. I went and looked for the definition to see if we actually had the proof, and yeah, there was nothing, no proof, can't use them. So what if I wanted to use test, but then I wanted to change it to some other version? Someone told me, oh hey, there's a better way of doing this thing, you should do that instead. But I don't want to fuck with my original definition of test. For example, let's say we have IOStream to print, and then we'll say this is a default test. Okie dokie. And then I can use test here, run the program, and then we get this is a default test. Okay. Well, what if someone said, oh hey, a better way of doing this actually is to make this print this thing instead. Okay, well, how do I do that? Do I just make a whole separate namespace and then make another function? Do I just delete this? Do I change the functionality here? I want to have version 2, version 1, and just be able to swap between one and the other, easy peasy. How do I do this? Really the best way, let's see. Hold. Hold. Hold, trying to remember. Because we're going to use unnamed namespaces and inline namespaces. And inline namespaces do the same thing. They put the things inside them in the scope of the namespace that the inline namespace is contained in. So for example, if I made this inline namespace test1, please don't do that. Then it's still hold. Wait, actually, maybe not. Hold. Wait, is the point that I just changed the whole namespace? Maybe that's actually the point. I could copy this whole thing. If I did that, and then I made him inline, and then I made this like that, that works. Because these two are separate namespaces. This guy's within, oh, actually this guy's within global scope now. This is not the right way to do it. I gotta figure this out. I don't remember. I don't use these, but I'm trying to use this as an example because the only reason I'm able to remember this at all is because of a quiz that I did way back when where I had no clue what they were. I totally forgot that inline namespace was a term and that unnamed namespaces was a term. And the only way I'm remembering this is because of the quiz back then. So quizzes are the best way to learn. So was the point that we go into this namespace, and then I have a second namespace. It's like, what happens if I had... Oh, is the point that it's just an inline unnamed namespace? Actually, that might have been the reason. Oh, but that fucking works? Okay. No. No, because if it's oh wait. Namespace thing doesn't work because this is a separate one, so I would have to say, well, it's not even known. Oh, it's, well, yeah, it's not even known here. I think the point has to be that we have two versions of the function. We have to start there. And one of these is in a namespace like this. That won't work because we get, oh, actually that's fine. Is that just the point? And so this is not a default test? So what happens if we run this? This is a default test. But if I instead put this guy within an unnamed namespace, and then take this guy out and call, wait, hold. What is fucking happening here? Can I just change the indenting of this whole thing? Hello? Fucking please? I can do that. Okay, so what happens? Can I go backwards like that? No? Edit. Advanced. Really? But it works from there? Hold, right? How many times is this gonna work? Will it work the one more time that I need it? Oh, fucking very good, devs. Doesn't work from here. Works elsewhere. If I select it all, doesn't work there. Okay, good. Awesome. But now we put the other guy in the name. Okay, interesting. So this puts void test in this scope, but it somehow prioritizes this guy and still makes the linker happy because this guy isn't seen by the linker, so he only sees one version. And because this guy exists, he's the only one that's called. Okay, interesting. So there's that. But what if it was inline namespace version 1, inline namespace version 2, though? I thought... It's been like 2-3 months. Huh. What if I just delete this, paste it all here in one file and see? So if we do this, we're cool. What if I put this within an inline namespace? I thought that the same shit would happen. Inline namespace thing. And it does. And so the point is we could have namespace version 1, namespace version 2. And so the strategy would be we have void test is a function, and it prints and says, this is a test. Okay. I need another version of this. This is version 1. I need a version 2. So what do? Well, I put this guy within a namespace and I call him version 1. And then I could make a copy of this and call it inline namespace version 2. And I don't have to go in and say, oh, hey, now you need to go test version 2 test. No. The inline namespace, just like an unnamed namespace, puts the shit inside it in the scope of the encompassing namespace. So it goes from in namespace version 2 to also being callable from namespace test. Is the point that this is only true in the same file? it can't be, because if I had some live or some crazy header shit and I had a million CPP files here and I went into this header, is the point that it's because it would be included in the header and it actually does require definition? I think I have to operate under that assumption, because inline const expression variables require definition in every file that they're going to be used in at compile time. So you have to include the header with the const expression inline, the inline const expression variable defined there. Same thing with the function everywhere it's used, because the compiler in each file needs to see a definition to it to substitute it for the actual logic itself. So the function doesn't even exist anymore after it's compiled. Okay, but the point here is this: I have test, but I need a separate version. How do I do it? And maybe I have a whole bunch of different functions, and I don't want to just copy them all and have them all cluttering up this one thing, and I need to hide one of them so that I can actually use the other. Well, I put the version we're going to use inside this version 2 inline namespace, and I put the version we're not going to use in this other namespace that's not unnamed, just a regular one. But the point is, if I wanted to call that version, I'd have to do test version 1, version 1, test. And that's fine. 2 different scopes, so it's cool. But okie doke. That's fine. So actually, now I need to go and generate a quiz about the shit. So we'll do CPP. My eyes are burning. Okay. We're going to start here all the way up through. I didn't do overloading like that. Didn't do smart pointers and move semantics yet. I started with objects before. Oh, wait, hold. What did I do? No, inheritance. That's it, because that's the main thing before smart pointers and other stuff. That's later. I've seen interviews for game development jobs, and they'll ask about smart pointers, but it makes more sense to understand basic object inheritance, because, for example, if I'm doing C#, does C# even have pointers? I was going to say that I don't think C# uses pointers, and if that's true, then using smart pointers might help understand some things, or at least what's happening maybe deeper, because maybe smart pointers are actually being used. They're just abstracted away. But I would need to understand the class functionality so that I can actually do the job. This is greater understanding. So, but that's just in case. I need to know both, but there's a hierarchy. I can't learn both simultaneously. So, unsafe keyword. Let's see. Okay. What? Bro, this is trash. Okay. Alright, so we'll do... Oh, well. Complexity was good last time I was using it, so... Okay, let's see what we get. Oh my fucking god, dude. Not this. That's not what I want. Okay. Try again, motherfucker. Oh my god. There's not good enough at AI, I guess, to tell him to just stop fucking doing this. Okay, fuck off. We're going to ChatGPT. ChatGPT is better. It's not fucking retarded like Perplexity. So bad. Rather, it doesn't fit my use case and my skill with it. My prompting is not good enough, but I don't give a fuck about prompting, dude. I'm trying to improve my brain, not get better at asking questions to AI. Oh, no. Nice. Very good. I didn't even ask and it's naming them. Great. Granted, next time I do this, then it might totally fuck up, but I'm not going to summarize this shit. No, I'm just doing the individual questions. Don't make me redo myself. Sick. Thanks. Okay. Cool. Okie dokie. Please critically evaluate my answers to these questions. In it, please be direct. Excuse me. Okay. 1.1. How far are we? 30 minutes? Easy. Time flies when you're having fun, yo. Alright. What is a statement in C++ and how does it relate to the basic structure of a program? A statement is an individual instruction for the program, which translates to an individual instruction for the computer, the processor, CPU. And a program is composed of statements, because if you don't have any statements, there aren't any instructions. So if we had a for loop, which isn't necessarily a statement, and there's nothing in it, then it doesn't do shit. So, okay. A statement is an individual instruction for the program to perform. Statements are the behavior of the program, and without them, the program would do nothing. Doesn't do shit. 1.2. Comments are used to explain code and improve, explain and format code, improving readability and comprehension, especially for yourself when reviewing past code or for others to review your code. 1.3. Okay, I want where the winds meet now. A variable is a named object that persists in memory beyond the statement it is defined in. Contrast to a temporary unnamed object. Oh, also, do not bitch and complain at me if I include information that's relevant to other questions in my answers. I like providing additional context because it enhances understanding. i.e., if you ask me what pointers are, don't fucking complain if I mention how they're different from references. Because I feel like explaining a bit extra. If you do this, you're gay. Alright, we should be good. Alright, so variable is a named object that persists in memory beyond the statement it is defined in, and its name can be used to access the value at its memory address in subsequent statements. Okay? Oh, I missed the how do you write them? Write single line comments via like this. This is a comment. And multi-line comments are like this. Between, oh yeah, okay. Okay, too many spaces here, I don't like this. Okay. Subsequent statements. What is a variable? Okay. And what does it mean that C++ is an object-oriented language? The statement that C++ is an object-oriented language means that C++ is not a procedural language that omits that does not have which does not have classes is not a procedural language, but instead a language that includes, what do we call it? Just object-related features? That includes, that is the object-oriented paradigm. Yeah. Including classes, structs, and their member functions and member variables, and properties like inheritance, encapsulation, polymorphism. Haven't touched this yet. I've touched inheritance and encapsulation. I'll do them in order, like encapsulation via access specifiers, inheritance with its different types of inheritance, each with their own with its own access, polymorphism, and I think we're missing another. Haven't gotten here yet, but I'm assuming that I imagine it involves overriding. Goods overriding functions. Virtual functions. Involves virtual and override functions where we specify where we write functions in derived classes, or where we write the behavior of base class functions in their derived classes. Okay? The statement that C++ is an object-oriented language means that C++ is not a procedural language which does not have classes structures, but instead a language that uses the object-oriented paradigm, including classes, structs, and their member functions, member variables, and properties like encapsulation, inheritance, and polymorphism. Haven't gotten here yet because but I imagine it involves virtual and override functions where we write the behavior of base class functions in the derived classes, or add existing functionality to them. Oh yeah, wasn't in inheritance we can add extra functionality by, isn't it, don't we just name the function to be the same as the base function? And we just call the base function from it, and then we add extra stuff? But that's not necessarily overriding. That's adding extra shit. And you have to assume that doesn't return a value, or that it uses that return value and then adjusts it and then does it. For example, if we said like get damage that we're doing to an enemy, okay, we get the damage, and we take that return value, and then we do the extra shit to it, and then we calculate the resistances and how much the damage really is. Because the armored monster inherits from the default monster, which doesn't have armor. Okay. 1.4. Initialization is assigning value to a variable. Well, hold. I guess to an object now. Because we initialize, yeah, we can't assign value to temporaries because they're destroyed after we use them and after they're defined. They're only used in that one instance. Initialization is, do we get an L value error if I even try to do that? I'm curious. Int. Okay. Right? Doesn't this mean, yeah, it is. Because we have to have a thing that we can modify with it. All right, cool. Good to know. Nice. That's what I thought. Is assigning value to an object during its definition. Assignment is assigning value to an object after its definition. i.e., int x is 5. This is, well, I'll write it in actual code so it'll be a standalone line. This is initialization because we assign x 5 with 5 at definition. Int y is 3. Or well, actually, x equals 8. This is assignment because we're assigning value to x after its definition and initialization. Okay, what is the difference? That's it. Wait, I'm stupid. 1.5. Actually, I should have. Okay. Character output, character input, and end line are objects defined inside the standard namespace, accessed via standard character output, standard character input, and standard end line. And included in a program by using include IOStream, which includes that piece of the standard library that defines those objects, which come from a pre-compiled header file. Bum, 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 bum. So the character output, outputs, or inserts text, or well, outputs text, or outputs characters using the insertion operator, operator insertion. Standard character input extracts input from the input buffer through the output buffer. No, I should actually, I don't have an arrow key, so I have to do this. I don't have any, so I gotta do that. Actually, can I? No, I can't. Okay. Extracts input via the, or through the input buffer using the extraction operator. Operator extraction. And standard inline is a character. This is the character. Is it an exit? No, it's not an exit code. Or do we call it a character? This is it. Alias, well, inline. Is a character that ends the current line. That ends the current line, like this, the actual, I guess, do we say backslash? I guess the backslash n, the actual inline character, ends the current line, like the inline character, but also forcefully flushes the output buffer, while inline character lets the buffer flush as it wishes. Or, well, does not forcefully flush the buffer. Examples: standard character output. Character output. I'm a fatso. Oops. Okay. Standard character input. That fucking scared me. Let me check if this. Wait back. Check something. Hold. Jesus, I got fucking Captain Yapathon here, dude. Fuck. Ugh, some guy talking about internet and shit. Whatever. Probably came in here and stole all my crypto. I have 0 crypto. Okay, let's go. I have negative crypto. All right. Music up. Where winds meet. Let's go. Back to it. I don't care, dude. Save $300. Doesn't matter. All right, let's go. Standard character input to existing variable. Or we'll just say X. Where X is a variable, we want to extract input of the matching type to ish, right? Yes. And then standard character output, well, standard end line. And this is the line effectively adding space to the console output, terminal output. Okie doke, 1.6. What is an uninitialized variable? Uninitialized variables are those defined but not initialized. This means but not initialized, so they keep the garbage value that existed in their that previously and currently exists at their memory address without initializing the variable to overwrite this. Well, using the variable without initializing, using an uninitialized variable means using an unknown value, which yields an undefined behavior. Let's see. Because if, for example, there was a pointer and it held the null pointer value, and then we destroyed that pointer, that address would still hold the null pointer value. And if we later created another variable that used that same memory address, and we used it without initializing it first, we would then crash the program because we're dereferencing null pointer. At least we would have an assert that says we'd have an exception thrown probably, which yields undefined behavior. Example, create pointer initialized with null pointer. Later destroy the pointer. Create or define new variable later, and it happens to be created at that same address. Still holds null pointer value. If used used without initializing it, if used without initializing it, we risk, well, if we just use the value, then it's, as long as we're not dereferencing, if we now run the risk of crashing the program, a thrown exception. If we use that address. Maybe not. If we assign value to it first, but no risk is better than risk. Sure. When the risk is crashing the program. Keywords are sequences of, well, not even sequences of characters, are words reserved by the C++ language that cannot be used as function names, or well, as function variable identifiers, because they have their own unique meaning. They might be, they are data types, excuse me, data types, control flow, not structures, control flow. I guess they're just control flow. They're data types, control flow, operators. Well, I guess they're not necessarily operators. Data types, control flow, and other built-in functionality. Like template. Am I fucking off course? I got a sweaty pit, bro, all because I had to stand outside for a fucking few seconds answering questions. I gotta wash my pits after this. That's amazing, dude. I love having a fucking sweaty armpit. It's 65 degrees outside. Unbelievable. Actually, no, it's probably in the 70s now because, okay, that makes sense. I'm used to 65 now, and 70, I'm gonna sweat, yo. Control flow, another built-in functionality, like templates, for example. Okay. White space is ignored by the compiler and lets us space out. Well, actually, see, because int x is a keyword, int x, doesn't it separate white space? Oh, comments are ignored, but white space separates identifiers, or well, how does it affect? White space separates identifiers and keywords. But beyond that is ignored, i.e. int x equals 5. Actually, I don't even know. Int x equals 5. Okay, it works still. It's the same as int x. If I, well, I don't want to do that. We could do, oh, can I do this? Oh, it's just not referenced. Okay, cool. But none. What is a literal? Literals are, fuck, how long have we been gone? Oh, that's it? 30 more minutes? Okay. Damn, 30 minutes for this chapter? Shoo! Literals. Oh, getting hungry. I don't think I'm gonna do all of it. I think I'm gonna skip after this chapter. Literals are, I mean, I guess we say temporary values, right? Temporary. I mean, the temporary values, they're not objects, right? I mean, because like an int 5 is an object somewhere that isn't given a name to refer to it, so it's only being used right then with the value 5. So it's initialized, it's not named. But it's not a literal. The 5 is the literal. Our values are values of a given data, values with a given data type that can be assigned to, I mean, are they R values? They are, right? Are values, specifically R values, L values, used anywhere that R values are used, like function arguments, values to be assigned to L values, etc. 1.10. An expression is, do we say it's code that evaluates to a result, or anything that evaluates to a result? Is, I guess I say is code that evaluates to a result in C++. Or rather, in C++, an expression is code that evaluates to a result. After defining an x is an expression, as is x plus 5, as is x times x, as is increment prefix increment operator, etc. As is do as is func x. Ooh, I forgot the syntax for lambdas. Oof, I just remembered that. I was gonna write a lambda. It's fine, I've never even seen it be used. It's fine for now. It's easy to pick up on. What are the essential parts? It's just a function that you define in line, in the text. What are the, they're named too. They can be. What are the essential, yeah, they don't have to be though. What are, you could define it and then reference it later. That way we don't have to, if it's only used in this one function, we might as well just use it in that one function, right? What are the essential parts of your first C++ program? All C++ programs need a main function because main is called when the program executes, and without it, the linker won't find and will error. Right? For example, if we compile now, boom. Because the executable is calling main. Because the executable, I guess, calls main, I think. Okay, what else? Functions, void, multi-file programs. Sure, we have 4 declarations. We got namespaces. We got inline const expression inline variables that we have to make inline because const expression variables they have internal linkage. We make them inline so that we can look for all those separate definitions even though they have internal linkage. So inline will make the const expression variables visible to the linker. Naming collisions, okay, preprocessor directives to have stuff happen before compilation even happens, which substitutes to text. For example, define x is 3, and oops, don't need that. Int main x plus plus. Oh, actually, it's not an R value, so we'll say int x. We can't do that either, so we'll say int y x. Boom, because x is 3, so we're just not using it right here. So we could just say maybe unused. I love how it's maybe. In programming, the science, we use the word maybe. Wow. Oh. What is the difference between syntax and semantic errors? I'm just going to respond to these, honestly. I think just going through them is more important than writing them all down. But writing down is important too. I'll write down the important ones that involve syntax. The difference between syntax and semantic errors. Syntax errors are ones that are caught by the compiler because it's a language error, whereas semantic are a meaning error, doing a for loop too many times, having a one-off error, having a loop not triggering because you did a while loop instead of a do while loop, where the condition is executed first in the while loop, Whereas in the do while loop, the do happens, the code executes, and then the while loop executes that determines whether or not it gets a second and further execution. Watching variables. I never even really touched this. I mean, we could just go into execution. Oh, here. We can go in here, and then where's it at? Oh, it's debug. Forgot. I gotta do minus, and then we can look at them. So we could say int x. Okay, it's 0. Hello? Oh, sorry. Maybe unused. Why is this still on? Function minus. Okay. So we can watch this variable to see how it changes over time to make sure that the function or the code, the function, whatever is behaving properly and that it's being updated to how we want, so we can identify semantic errors. Stepping in a debugger is stepping through each line of code to watch variables and see what's happening and see that execution, that control flow is happening correctly. And as expected, breakpoints are used so that if we don't want to step through every single thing, I could set a breakpoint here and I want to step through after. I set a breakpoint here, I run execution, it stops at that statement. Here there are no statements. This is all white space because comments are ignored by the compiler. So it wouldn't stop there. It would go to the first statement that it would see. Cool. Find issues because the time to solve problems the time spent solving issues is greater than the time spent writing code in the first place. So if you can find the issues in the first place and spend that time in advance, one, it's time you don't spend later, and two, it's time spent resolving issues before they take even more time because the issues interact, compile, complexify, and then they take more time to solve. Size of returns the size of the data type if a data type is passed in, but it has overloads, so you can also pass it objects and it will get the objects or the data type of that object. It will actually give you the size of that specific object. So if you had an array of 12 integers, it'll say, 48, but maybe there's some sort of padding going on and it's actually 52 bytes instead. So maybe there's like one extra. Fundamental data type is data of the fundamental types, including, well, are we saying fundamental like that? Right, so we're saying integers, characters, booleans. I think that's it, huh? Not floats, not longs, not doubles. Maybe something like that. The void type is used to represent no value. So for a function, we return void because there's nothing. Void is also used in the context because of operator overloading. Void can be used with the multiplication operator, but really it's the pointer operator. So we make a pointer to void. And what happens when we have a pointer to void? We have a pointer that can point to anything, but we can't dereference it. It can hold any address to anything, whereas a pointer to an int can't hold a pointer, a pointer to an int cannot hold the address of a Boolean value, but it can hold that of an int, but it can also be dereferenced. But a void pointer can hold the address of anything, so we could use it for any kind of object we want. We can't dereference it though. Signed integers have memory that's fully dedicated to positive and negative values, whereas unsigned, all the memory is dedicated to positive values. Thus, unsigned variables of the same memory size as their signed counterparts have twice as many positive numbers and no negative numbers. For example, 0 to fucking 20,000 would be negative 10,000 to 9999 for assigned, but those aren't real values. So you could do like 63,000, something like that. I think I don't remember the numbers at this point. I've already forgotten them, but it's like 5.3 billion or something like that for an int 64. Maybe it's an int 32. I don't remember. Fixed with integers. So integer data types in C++ have a minimum size, but there's no guarantee for the maximum size. For example, the minimum size of an integer is 4, but integers can be longer. Fixed with guarantees that the size will max out at that, and it will be exactly that. For example, an int 16 is an integer that only takes up 16 bits, 2 bytes instead of 4 bytes. An int 32 is a standard integer on x64 systems. Whereas a short, I think, is it on 32 systems. You could use long, and long is probably a 64-bit 8-byte integer, or you could do an int64 to actually make sure that it is an int64. Scientific notation, 3e10 is 3 times 10 to the 10th. 3e negative 6 is 0.00006. I think I said, or sorry, 3. 0.00003. Floating point numbers are numbers where the numbers with decimals, and the decimals in C++ are represented in binary fractions. Binary fractions implicitly have error inside them just because of how they're represented. So the equivalence operator is not helpful. Excuse me. Equivalence operator is not helpful. You're better using, what do they call it? I mean, I guess they call it a lambda, but you have some variable that you set to be your tolerance, and you say, is this number minus this number, or is the absolute value of this number minus the absolute value of this number? If they're equal, it should be 0. But because the binary fractions don't give us an accurate result if they're equal, because 0.1 plus 0.1 plus 0.1, because of binary fractions, will have rounding, whereas 0.3 doesn't, or well, also has it, but there's no operation on 0.3. So if we do 0.1, it has rounding error. So if I compare 0.1 to 0.1, we probably get true as equal. But if we say 0.1 plus 0.1 and compared to 0.2, probably don't, because we get rounding error plus rounding error. It's probably significant enough for it to no longer be equal to 0.2. So we instead say absolute value of 0.2 minus absolute value of 0.1 plus 0.1. Is that less than our tolerance? So if we say it's 0.01, it probably is. If it's 0.001 or 0.0001, maybe not. We use a lambda, that tolerance value, to compare floating point values because of the binary fraction limitation of C++. It's probably for C too. A character is one of the fundamental types. It's one of the 127, I guess, or well, 128, or is it 256? I don't remember. One of some number of. Or is it 64? No, it's not. It can't be 64 because 97 is lowercase a, right? And 65 is uppercase. So I think it's 128. The ASCII characters. A character is one of those ASCII characters, different from an integer, and specifically it's 48 above the integer that represents it. So if we subtract 48 from the 0 character, we'll get 0. Right? Static cast is, I guess, a function that takes an object and returns another object of the destination type, and the compiler will error if there's no conversion between the two. So if I want to convert an integer to a double, I could just, well, if I wanted to convert an integer to a double, I could just assign the double the integer and it's fine. But if I wanted to, really a good use case is if I wanted to convert a double to an integer and I'm okay with losing the rounding because we're going to lose the end of the floating point value, we do static cast to an int that double value and it will yield an int. And then I can assign that value to an int without getting a narrowing conversion error. A named constant is a variable that is constant that has a name that we can reference later, but we can't assign value to the constant after initialization. So no assignment. Literal, I already explained that earlier. For numeral systems, I mean, there's decimal, there's hexadecimal, there's, what is it, twos or something? Oh, there's binary. And then was there octa or some shit like that? The as if rule means that the compiler can optimize the program and do whatever the fuck it wants. Do as if, I don't know why it's called as if, but it can do whatever the hell it wants as long as it doesn't affect behavior. Constant expression is an expression that, well, a constant expression is one that we'll evaluate at compile time. A constant expression variable is one that can be used in a constant expression, and constant expressions require the variables inside them to be constant expressions. Constant expressions must be composed of constant expressions, i.e., literals, R values, or variables that are made constant expression that are evaluated at compile time, and then symbolic substitution will substitute them to their literal values, which are substituted and propagated throughout the whole program, so that you go from having constant expression int x 5, initialized with 5, to 5 everywhere that x is referenced. And the compiler does that, so that when the code is ran, there's no runtime memory shit happening with that 5. Or at least with the variable. The 5 is probably stored somewhere, but there's no actual box on it. There's no cost of having to go to it, I think. A standard string is an object from the standard library that can contain a sequence of characters. It has a bunch of data members, just like standard vector. It's basically a standard vector, just for character. It's basically a standard vector of type character. Standard string view is basically a standard string. It's basically a const standard string reference. It's an object that you assign with a standard string or with a C-style string, and it basically just binds or holds the address of whatever holds that, but it's as a const, so it treats it as a const. It's like a pointer to const, so you can't change the value there through the standard string. But it's an easy, cheap way of passing expensive standard strings that if you already have from place to place. And it's kind of your universal, I need to pass a sequence of characters from somewhere to somewhere without using the C-style string bullshit syntax and all the looping and shit required in there. Cheaply, because we're not copying the entire object, which is expensive because standard strings are an expensive built-in class in the standard library. Operator precedence is the order that operators evaluate in. For example, x minus y plus 3. Operator plus, I believe, operates first, so plus is going to happen first, so it's going to be y plus 3, and then it's going to be x minus that whole thingy. Associativity is right to left, where they evaluate. So if two things are the same, which one's going to go first? Associativity tells us that. So if we had x plus 5 plus 3, we go from the right. Most things are right to left, so it would be 3 plus y plus x, basically. So it'd be 3 plus y, done, y plus, that result plus x. The basic arithmetic operators, plus, minus, divide, remainder, multiplication, right? Plus, minus, divide, multiplication, remainder. The remainder operator returns the remainder, meaning the remainder left after doing division. So the integer remainder. So for example, if we say 7 remainder 3, what do? We say how many times does 3 fit into 7? 2. Okay, so we get 2 is the result. Or sorry, 2 is how many goes in. How much is left over? 1. What's the result? 1. So we can check if something is divisible by something by checking if the remainder is 0. If the remainder is 0, then the divisor or whatever, the second number fits within the first number evenly if the remainder is 0, because nothing is left. Side effects related to increment decrement. Okay, so not only do they increase the L value by 1, they also, or decrease it by 1, increase or decrease by 1, but they also actually change the value there. They assign the value to be that result. They assign the object. Comma operator makes it so that the left-hand guy operates first. When you evaluate an expression with a comma operator, it evaluates to the left hand. So, for example, if we did x comma y colon, it evaluates to x. I'm trying to think of another example. Yeah. It's fine. Conditional operator is used as like we want to return 2 values using one Boolean. Instead of saying if this, if it's true, return this, and then else, if it's false, do this. We instead just say in parentheses the Boolean check colon space, or hold on. comma, or that we do the Boolean, the expression that's Boolean, and then a question mark, and then the true value, and then semicolon, and then the colon, and then the false value. Example. We'll say int x, and we're going to assign him to b. Is x greater than 1? 3, otherwise 4. Okay, x is, oh, well, I can't say that. We'll say, is 3 greater than 1? 3 is greater than 1, so it's going to be 3. Boom. So, if I include standard character output, well, I didn't mean to do the quotes, but it doesn't matter. Conditional operator, same thing as the ternary operator because it has 3 operands. 1, question mark 2, colon 3. Floating point comparisons are tricky because of what I explained earlier with the binary fraction representation. A bit flag is an unsigned integer that we use to compare to another unsigned integer that's in binary to check whether a particular bit is on or off and to set that bit on or off. So I can check by comparing a binary integer, well, an unsigned integer really, to the bit flag. And if I say, well, fuck. Forgetting. I gotta write some shit. Could do but we'll just do unsigned int. Or we could say uint 8tx. And so, I mean, if we're doing that, we might as well say that, right? And then we could say uint 8t first flag, or flag 1 is the first bit, so it's same thing. And we could output hold, because and equals will assign that value, right? We say x and equals something. I assign x to be the result of it and that, where we compare them all. The bits that are shared. Isn't that the point here? Oh, that is the point. Because if these guys, if the and equals result of these is 1, then it means that The only thing well, it means that the only bit that's positive here has to be true here, which means this guy has to be set. So we say, is X true or is X, what do we call it? There's like an on-off version when you do the, when you include bit set. Is X on? Or is X's first bit on? This is the 1, 2, 3, 4, 5, 6, 7, 8 bit, not 1, 2, 3, 1, 2, 3. Excuse me. Let me say X. Oh, I guess we do that. That's it. X and flag 1. Or we could do X and flag 1. Right? Hold. Why not? Wait. Is it? Wait, what is happening here? Hold. What if I did U and AT result? X and flag 1. That's fine. Wait, hold. From int? Where's the narrowing? Oh, is it too big? Because 1, 2, 3. Oh, okay. So it should be. Should this just be unsigned int? How many of these do we get? Which one is it? It's line 87? Oh. Oh, wait, what? So what if I... Please. X and that. The result of that is an int, but why? What if I said 16? Really? What if I did int 32? Still int 64? Because int 64 is bigger than an int, so. Still! Oh, wait, are we getting some negative shit? Oh, we're doing... There's some const expression stuff here. Because it's const expression, this is fine. So this is still fine, okay. I'm not super sure why. Why is this result? I'm not sure why the result is flagging as an integer. Oh, wait, hold. I need to static cast this to be an int. Or rather. But if I make this 0, but I make any other of them 1, it's false because these are not shared. So something like that. Yeah, fuck it. I'm not even going to paste this stuff in. I'm just talking about them. How far are we? Hour and a half, okay. I'll do till chapter 10, and then I'll do the rest of the stuff later. Oh, fuck me. All right. What does a bitwise operator do? So the bitwise operator, I don't like or equals, which is, I think, what is XOR? I think it's just that, right? Or it's, fuck, what is XOR? It's not, there's and equals, there's or equal, or there's and equals, there's or equals. Why? Oh, wait, well. Versus, or, not that, or equals. Is it ampersand equal? It is or, like that, I think. And the point is it assigns the result. I think if this is XOR, like that. Oh, is it? This would flip them all. So this will say, wait, like, is it the opposite? Is it the opposite? So in this case, it'd be false. But if it was and equals, that would still print to be false because we're still getting 0 because none of them are, well, none of them are true in both, but they're false in both. And then or as if either are false. The point is that that assigns the return value to our L value on the left. The bit, oh sorry, so the bit flag, those are the bit masks. The bit flag is our unsigned int that represents a bit, I think. And then converting between binary and decimal. Converting between binary and decimal, we could just do the power multiplication. So we just take the first, we use the bitwise left shift. So if we pass in binary, I think we, what is it? There's like dot last in bit set, but here, but don't we do, do we check with the remainder of 1? I think we check to see if it's 1 or 0, and then we multiply that by whatever, and then we shift it right 1, and assign that, and save that, and then we check, and then we can keep going. I think that's how we do that. A block, also known as a complex statement, is when we have the starting brace and ending brace. Starting brace and ending brace, and execute all the statements between them. Objects declared or defined inside or destroyed at the end. User-defined namespace, those are ones we've already made. We've already talked about local variables, global variables. Those exist from the start of the program start till the program end. They're accessible everywhere, whereas local variables are only created in the function destroyed at the end of the block. Internal linkage hidden from compiler, from linker, external visible to it. Non-const global is discouraged because it can be changed anywhere, unsafe. Inline functions variables, those are allowed to be multiply defined elsewhere, and the linker will find the multiple definitions and link them up. That way you don't have to redefine the same shit. Purpose of sharing inline files, variables across files to avoid duplicate. Well, one, to avoid, like if we had a function, well, if it was a function, we avoid the one definition rule. If it's an inline variable, like a const expression global, then the benefit is saving memory. So instead of having this constant that exists here and here and here and here and here, instead we can look at one place in memory. By making them inline, the linker will deduplicate them so that it's only actually defined at runtime once. The difference between scope, duration, and linkage. Scope is where things are visible. Duration is how long something lasts, and linkage is the files in which they're visible. So internal linkage, nothing in other files can, or no other files can access the stuff in this file that has internal linkage. Duration is, well, duration is just how long it lasts. So for example, duration of local variables is from definition to the end of the block, end of the function, same thing. Whereas scope is where they're accessible anywhere within the function and destroyed at the end. So duration is like how long it's actually in scope. It's accessible here, but if it's destroyed before because the end of the block, then okay. A using declaration. A using declaration brings into scope a namespace. Specifically, it brings in one identifier using standard character output versus using namespace standard. That's a using directive, and that brings the entire namespace in. Inline namespace we already went over earlier. Control flow, the flow of the code, how we determine what happens, choices, uncertainty. It's how we handle all of that. Like if statement, check the condition. If it's true, we do this. If it's not, we do this. This all ties into flow. Switch case, a known value that we have, or a value we receive, a bunch of known values, maybe a default statement or a default case, and then we execute the proper logic, preventing fall through at the same time with breaks and returns. Const expression if is what we need when the if statement's expression is known at compile time. Common mistake with if statements. Oh, well, if you put a semicolon right after, then it's an empty if statement. You put a null statement, they call it an empty statement right after, and then it won't execute. That might be one. A common mistake with if statements. I mean, I'd say the more common mistake is using an if statement instead of just returning the Boolean value that returns true or false. Instead of saying if this, return this, if this, return this. If true, return true, if false, return false, or if true, return whatever. Something like that. Or instead of doing that, we could do a ternary. So return if statement 4:3. Instead of saying if true, return 4, if false, return 3, or else if return 3, or else return 3. Switch statement, already said that. Switch fall through, already said that. A go-to statement, we create something like this. What did we actually say? Did we say go to X? I don't remember how we write the go-tos because that gives you spaghetti code. Allegedly. Label? What do we call it? I mean, they're called labels. A go-to statement is a statement we execute that moves execution to another line. You can make infinite loops this way. You can skip code this way. Oh, X. Wait, oh, that is it. It is blocked like that. Okay, cool. It's a colon, not a semicolon. While loop checks a condition, then executes logic inside. Do while executes logic, then checks to see if it's going to continue. For loop used for specific amount of iterations needed for the loop. From here to here, do this instead of some unknown stuff. Break and continue. Break breaks out of the inner loop. Break exits the innermost loop, huh? Continue goes to the next iteration of the loop, or continues after if it's the last iteration already. Break exits the innermost loop. And also switch statement. Not function though. Program halt. If we do standard abort, it will end the program there. Random number generator. Oh, we want some random behavior. We want stuff to change beyond what the program has in the beginning. We want to start the program. We want something to happen different from the last time we ran it. Well, we need to get a random number generator to generate something approximately randomly. So a pseudo random number generator. Random.h has the standard random device, the standard Mersenne twister 10937. It also doesn't have standard chrono. It does have standard seed sequence, which we can use to initialize with 8 different integers to pass to a Mersenne twister, which will yield a very good seed. High periodicity, so it's not repeating itself very often, and it's a big number in general. Test code, save time, yo, make sure the shit works. Works to save time by finding problems and validating things as we go by using, what do we call them? Unit tests. Before we integrate new units, code coverage is how much of the code, what percent of the code is tested by the unit or by the unit test. Common semantic error. There are a bunch of them. I've already talked about them. Like null statement after the for loop. One-off errors in the for loop by initializing your counter with 1 versus 0, or being less than instead of less than or equal, or greater instead of greater than or equal. Error handling. Have print statements to handle errors. Have exceptions thrown that are handled later. I don't know how to throw or handle exceptions yet. Use standard optionals to return possibly empty results instead of sentinel values that you have to know what the value actually means when you see the error code 7. What does 7 mean? Instead, you could just return nothing and print when you return to say what's happening. You could use assertions as well to handle them. So if every tick you check whether the character is inside the level's volume, the bounds of the level, you can assert that it's within range. If it's out, then the computer or the program will end. However, asserts get compiled out. Asserts will get compiled out when you use a release build, because when you use a release build, it will include, or it will define ndebug. And if ndebug is defined, then the asserts will be compiled out. So what you should also do is use if statements to check, and those will abort too, because asserts will only happen when you're in debug mode. Implicit type conversion is when you convert from one data type to another when you're doing regular assignment or regular, and that's kind of, or when you're doing regular expressions. 4.3 plus 2. Okay, well, what happens? Do we get 6 or do we get 6.3? Or 6. Yeah, or do we get 6.3? Well, the rules state that the usual conversion rules state that 2 integers will convert to the floating point value of the same memory, or at least of the type they're being evaluated with. So in this case, a float, 4 bytes probably. So integer gets converted to a float, and boom. 2 floats, boom, 6.3. Numeric promotion. Numeric promotion is when we go from data of one type and it is converted to another type without risk of narrowing conversion. That is more efficient for the compiler to use. For example, adding a short and an int. The short will be numerically converted to, or numerically promoted to an integer, because integer is more efficient for a times64 system to run. And our return, our results is an integer. I'm stuttering because I'm trying to correct myself as fast as possible. because I need to fucking eat right now. I'm getting pissed off. What is a numeric conversion? Numeric conversion, same thing basically, but without the improved. Well, without staying in the same type of data. So if we convert from a character to an integer, it's not numeric conversion or promotion, it's numeric conversion, because characters and integers are separate types of data. And it's not happening, and the conversion is not happening for efficiency purposes. It's like the result type of 2 shorts might also still numerically promote, because integers are better for times64 systems. Nearing conversion is when you convert from one data type that takes up some amount of memory to another data type that is smaller. For example, assigning a float to an integer, or assigning a floating point value. And the point is, it's not more memory, sorry. It's that the destination type cannot represent cannot represent all values of the starting type. Integers cannot represent all values of floating point, or all floating point values. Therefore, a float to an int is a is a narrowing conversion. It's not necessarily safe or unsafe, but in this case, it is unsafe because decimals are not. Well, it's unsafe because we're actually losing value, whereas numeric promotions are safe conversions because we're not losing value. All values can be represented. So if the values can't all be represented, then it's unsafe. You can use static casts to explicitly convert to do narrowing conversions and tell the compiler not to error, because the compiler will error if you do implicit narrowing conversions. Arithmetic conversions are those are just the conversions that happen when you do an expression, when you do arithmetic, plus, minus, divide, remainder, multiplication. A type alias is an alias for a type to save us time typing it or to improve clarity. For example, standard vector less than bracket standard vector less than bracket, standard vector less than bracket, standard string greater than bracket, space bookshelf would be one object, or well, I guess that itself, a standard vector of standard vectors of strings is a type. But we could say using bookshelf equals assigned equals is being used as the alias, or we could say type def. Actually, it would be using standard vector standard string equals bookshelf, or type def bookshelf. Boom. That way we can use bookshelf instead of saying I have a vector of standard string vectors. Each page is a long string, and an array of pages is a book. An array of arrays of pages, an array of books, is a bookshelf. Auto, for object types, yields type deduction. Auto makes the type of the object match its initializer. If it's not initialized, auto will not work. Also works for return types too. It'll create an object of a return type, or it'll return an object of that type. Type deduction applies for functions by putting auto in the beginning of the function, and it will return the proper thing. For example, if I say int main void do thing auto get do thing address return do thing That's the address of do thing. I got it with auto. I could instead return hold void point. Wait, I actually don't know. Excuse me. We could do standard function and do a pointer, I think, that way, but it's not. Wait, is it that? Okay, it is just void pointer. Or we could do. Well, if it's void pointer, we may as well make it void pointer. It's not a pointer to a void with nothing? I'm not super sure the syntax there, but so auto is helpful in that case. Okay, I'll continue with chapter 11 after I eat later.